In 2022, astronomers celebrated a cosmic milestone. Hubble Space Telescope spotted a pinpoint of light whose journey began nearly 13 billion years ago. They named it Earendel, pronounced Earendel, and called it the most distant single star ever observed. But now, the James Webb Space Telescope, the sharpest eye we've ever aimed at the cosmos, is challenging that claim. Webb's data hint that Earendel might not be a lone, massive star but a compact cluster of stars bound together by gravity. In this video, we'll break down how Earendel was discovered, what JWST has revealed, and why the answer, star or cluster, could reshape our understanding of the universe's first billion years. Astronomers using the Hubble Space Telescope were observing a distant galaxy nicknamed the Sunrise Arc, a faint, stretched-out smear of light about 900 million years after the Big Bang. In that arc, they spotted something extraordinary, a single, brilliant point of light. A massive foreground galaxy cluster sits between us and the Sunrise Arc. Its gravity bends and magnifies the light from objects far behind it, acting like a gigantic natural telescope. In Earendel's case, this magnification was extreme, more than 4,000 times brighter than it would otherwise appear. Without this perfect alignment, Earendel would have been invisible. With it, astronomers could study its light and estimate its properties. They concluded it might be a single star 50 to 100 times the mass of our Sun, a potential analogue of the universe's very first stars, the elusive population 3 stars. The headlines wrote themselves, "Hubble spots the most distant star ever seen." But even then, astronomers knew Hubble's image was just too blurred to prove it was one star. It could also be a small, dense group of stars masquerading as a single point of light. That mystery had to wait for a sharper telescope. Enter the James Webb Space Telescope in 2023 and 2024. Webb has much larger mirrors and sees in infrared light, which is crucial for peering through cosmic dust and observing very distant objects whose light is stretched by the expansion of the universe. When JWST turned its instruments toward Earendel, astronomers got 2 powerful upgrades: much deeper, sharper images and, more importantly, spectroscopic data. The fingerprint of light using its NIRSpec instrument, Webb collected Earendel's spectrum, showing how its brightness varies with wavelength. This is like having not just a photo of a candle but its chemical signature, temperature, and flame shape all at once. The results were surprising. Earendel's spectrum did not perfectly match the profile of a single massive, hot star. Instead, it could also be explained by a compact star cluster made of several stars bound together by gravity. Models of such clusters, especially ones with low metallicity, meaning very few elements heavier than hydrogen and helium, fit the data well. And that's exactly what astronomers expect for early stellar systems in a young, chemically pristine universe. At JWST's resolution, the light from a lensed star and from a compact cluster can still look similar. But the absence of certain spectral features tied specifically to hot, massive stars raised doubts about the single star interpretation. Astronomers are now continuously monitoring Earendel for these changes. If its brightness flickers the way a lone star should, that's evidence for the single star scenario. If it stays stable, the cluster hypothesis grows stronger. We're still in the middle of that observation campaign. For now, JWST has shifted the balance of evidence toward compact cluster, but it hasn't fully ruled out the possibility of a single massive star, or even a binary system of 2 stars. If Earendel is truly a single, massive star, it remains the most distant one ever observed. That would make it an unparalleled probe of early stellar physics, possibly giving us our first direct glimpse of stars like the theoretical population 3 stars. These first-generation stars were thought to be enormous, short-lived, and crucial for seeding the universe with heavier elements. On the other hand, if Earendel is instead a compact star cluster, it would be the earliest such cluster ever detected. That would show that dense groups of stars were already forming in the early universe, just a few 100 million years after the Big Bang. This would reshape our models of how galaxies assembled their first stellar populations. Either way, Earendel is rewriting the history of the cosmos. It's a reminder that the first billion years after the Big Bang, the so-called cosmic dawn, wasn't a slow, gentle era but a time of rapid star formation, fierce radiation, and dynamic structures. This is only the beginning. JWST is scheduled to keep observing Earendel and similar ultra-distant objects. Each new data set adds clues about its true nature. Future telescopes, like the Nancy Grace Roman Space Telescope and ground-based extremely large telescopes, will offer even sharper views and more sensitive spectra. By combining all these observations, astronomers hope to pin down whether Earendel is a lone star blazing across time or a dense cluster shining as one. Whichever answer we get, it will be historic. If it's a single star, we'll have the oldest, farthest starlight humanity has ever captured. If it's a cluster, we'll have found the earliest known star cluster, pushing the record for bound stellar systems deeper into the past. Either way, Earendel serves as a beacon from the universe's infancy, a reminder of how far our technology and curiosity have taken us. So the next time you look up at the night sky, think about this: there's a tiny dot of light, magnified by a cosmic lens, that left its home almost 13 billion years ago and is just now reaching our telescopes. Whether it's a single star or a family of stars, Earendel carries the story of the universe's youth, a story we're only beginning to read. If you enjoyed this journey into the early universe, subscribe for more space explorations. We cover the mysteries of the cosmos, from hidden moons to interstellar visitors, bringing you the most exciting discoveries from NASA, JWST, and beyond. Drop your thoughts in the comments. Do you think Earendel is a lone star or a star cluster? Why? Thank you for watching my channel.